Okay, so good morning. As we will be discussing the random errors in chemical analysis. As we can see, the nature of random errors, they are indeterminate. Errors can never be totally eliminated and are often the major source of uncertainty and determination. So here are, for example, here's the in table example 4-1, the following results were obtained in the replicate determination of the lead content of a blood sample: 0.752, 0.756, 0.752, 0.751, and 0.760 parts per minute na lead. Find the mean and standard deviation of this set of data. Since it's the error that we are trying to find out, here is what we are going to do. As you can observe here, you need first to organize it in a tabular manner. Okay, here are the sample and the replicate number, and here are the data that gathered. First, you need to get the average of the data, and then as we can see here, mean, as usual, the average of data, and then divided by the number of population, and then you will get the mean. And okay, the next thing that you will do is that you will get the squared of the data. For example here, 0.752 squared, and you will get 0.56554, and so on. And then you will also get the total of that, the summation notation of the squared of the date of our data, and that will give you a total of 2.844145, and that is what you call the long method. Okay, and this is the short method. The short method is summation notation of our data squared divided by n. So we have our total here, 3.771, and then you squared it. That will give you 14.220441 divided by the number of population. That will give you 2.8440882, and that is your short method. Okay, so we need to substitute here kasi yung sample standard deviation natin is ito yung formula, summation notation of data squared minus summation notation of our data divided by our population, and overall divided by our population minus 1. So, i-substitute na natin dito. We already have the summation notation of our squared, which is this one, yung long method natin, the 2.844145, and then i-deduct natin ngayon yung sa short method natin kanina, yung short method ito na formula, which is 2.844082, and then overall tingnan natin dito yung formula, n minus 1, so 5 minus 1, that will give us 4. So, i-deduct mo lang itong dalawa, that will give you this answer, divide 4, and that will give you 0.00377, or using the significant figure of 3.004 parts per minute of lead. And this is also how you get the variance. So, yung variance natin, ganito yung symbol, S squared. Madali lang siya. Yung kanina kinuha natin na standard deviation, is-squared mo lang. So, titingnan natin, 0.0038. Nandito yung nasa makita. No? So, 0.0038. Kasi ginamit niya is for significant figure. Mas maraming significant figure, mas accurate yung result natin. So, as much as possible, ganito yung gagawin natin. So, ginamit niya is 0.0038, and then squared mo lang, that will give you your variance. So, 0.0038 squared, that will give you 1.4 times 10 to the power of negative 5. Okay, yun sa RSD naman natin in PPT. When you say PPT parts per trillion, ganito natin siya i-solve. So, yung standard deviation natin kanina, i-divide natin sa mean, and then times 1000 PPT, that will give you 5.0 PPT. So, si coefficient of variation naman natin, paano siya kunin? Yung sample standard deviation divided by mean times 100%, that will give you 0.50%. So, si range natin with the symbol W. Okay. Yung pinaka malaki na data minus pinakamaliit na data. That will give you 0.009 ppm. Yan.